The planetary system we call home is located in the outer spiral arm of the Milky Way galaxy. Our solar system consists in our star, the Sun, and everything bound to it by gravity, the planets, and some dwarf planets such as Pluto, dozens of moons and millions of asteroids, comets and meteorites. Beyond our own solar system, there are more planets than stars in night sky. So far, we have discovered thousands of planetary systems orbiting other stars in the Milky Way, with more planets being found all the time. Most of the hundreds of billions of stars in our galaxy are thought to have planets in their own, and the Milky Way is but one of perhaps 100 million galaxies in the universe. While our planet in some ways a mere speck of the vast cosmos, we have a lot of company out there. It seems that we live in a universe packed with planets, a web of countless stars accompanied by families of objects, perhaps some with life in their own. Our solar system formed about 4.5 billion years ago from a dense cloud of interstellar gas and dust. The cloud collapsed, possible due to a shock wave of a nearby exploding star, called a supernova. When this dust cloud collapsed, it formed a solar nebula, a spinning, swirling disk of material. At this center, gravity pulled more and more material in. Eventually, the pressure in core was so great that hydrogen atoms at the center, gravity pulled more and more material in. Eventually, the pressure in the core was so great that hydrogen atoms began to combine and form helium, releasing a tremendous amount of energy. With that, our Sun was born, and eventually amassed more than 99% of the available matter. Matter further out of the disk was also clumping together. These clumps smashed into one another, forming larger and larger objects. Some of them grew big enough to their gravity to shape them into spheres, becoming planets, dwarf planets in large moons. In other cases, planets did not form. The asteroid belt made of bits of pieces of the early solar system that could never quite come together into a planet. Other smaller leftover pieces become asteroids, comets, meteorites, and the small irregular moons. In order and arrangement of the planets and other bodies in our solar system is due the way the solar system formed. Nearest the Sun, only rocky material could withstand the heat when the solar system was young. For this reason, the first planets, Mercury, Venus, Earth, and Mars, are terrestrial planets. They are small with solid rock surfaces. Meanwhile, materials were used to see as ice, liquid, or gas settled in the outer regions of the young solar system. Gravity put this material together, and that is where we find gas giants Jupiter and Saturn, and ice giants Uranus and Neptune. Light is the fastest thing we know. It's so fast that we measure enormous distances by how long it takes for light to travel then. In 1 year, light travels about 6 trillion miles, a distance we call 1 light year. To give you an idea of just how far it is, the Moon, which took the Apollo astronauts 4 days to reach, is only 1 light second from Earth. Meanwhile, the nearest star beyond our Sun is Proxima Centauri, is 4.24 light years away. Our Milky Way is in order to 100,000 light years across. So gravity is one of the main forces that drives the universe. For example, Jupiter does not orbit the Sun. Are you surprised? In fact, the Sun and the planet orbit a combined center of gravity, and that is true for every planet in your solar system. However, Earth is so small that it basically orbits the center of the Sun. So, you learn in the school, astronomers say it all the time, it's the truth. Earth cycles the Sun. Well, almost. Earth does travel around the Sun, but the path is not a perfect cycle. It's elliptic, slightly loop-sided. One end is a bit closer to the Sun than the other. On January 4th, our planet is at the closest end, a point astronomers call perihelion. We all be closer to the Sun than we are at any other time of the year. All planets in our solar system travels around the Sun in elliptical orbit. It's the Kepler's first law. So the eccentricity of Earth's orbit is 1.7%. In January, when we are close to the Sun, perihelion, the distance is 147.5 million kilometers versus 152.6 million kilometers in July, the farthest point, or aphelion. A nearby sun means more sunlight for our planet. Average over the globe, sunlight falling Earth at perihelion is about 7% more intense than it's at aphelion. How about solar energy? Our star is responsible for keeping our planet warm, like a giant thermonuclear furnace with a temperature of 15 million degrees Celsius at its center and 6,000 degrees Celsius on its outer surface. Through nuclear fusion of hydrogen nuclei, pairs collide, releasing energy and forming helium. Every second, our Sun is losing 4.3 billion kilograms in mass converted into energy. The Sun's principal energy releases the solar wind and spends energy in portions of the electromagnetic spectrum. The surface of the Sun is a very busy place, and it has electricity-charged gas that generate areas of powerful magnetic forces. These areas are called magnetic fields. The sun gases are constantly moving, which tangle, stretch, and twist the magnetic field. This motion creates a lot of activity on the sun's surface, called solar activity. Sometimes the sun's surface is very active, other times things are a bit quieter. The amount of solar activity changes with the stage of the solar cycle. Solar activity can have effects here on Earth, so scientists closely monitor solar activity